Okay, we're going to use the graphing utility to find the points of intersection, if any, of the graphs and of the function. All right, so let's put those in. All right, and your proof is that you're going to sketch your graph for me. So I'm going to do a doc B and get rid of what's there. We're going to go into here, and it is 100e to the 0.01x. So 100, remember e is here. 0.01x. So everybody get that typed. You want to practice this with us because there's some zooming stuff that we have to do that's not pretty. Okay? So you want to make sure you practice, because if you hit something like this on, say, the final exam, you'd want to be prepared for it. Okay, I'm going to hit enter. Oh, it didn't come up, did it? All right, because it is not in the window. Let's deal with the window in a minute. All right, let's put that other number in. So there's a second equation. It was 12,500, which should just be a horizontal line. And again, you hit enter. You're not going to see it. It's not in our window. So the first thing I do, even though I already know that this doesn't work, okay, but this is the first thing I do, okay, is I go to menu, and I go to window zoom, and I go down to the zoom fit. Basically, I have to play hide and go seek with my graph and try to find it. So this is a good place to start. So I'm going to click that button. Unfortunately, my other line didn't come up, right? And we know it's supposed to look exponential, and that does not look exponential. That looks linear. But at least it's a place to start. At least I got it to appear. So the next thing I'm going to do is I'm going to come up here to menu. And we're going to go back to that window zoom, and this time go to window settings. And let's adjust our X min and our X max. I don't know, what number do you think we should start at? 1,000? Okay, let's try 1,000, see what happens. Playing hide and go seek. Alright, so I'm going to go 1,000, 1,000. What about the Y min? We really shouldn't go negative, right? The asymptote was 0, so I'm going to go negative like 100. Just so I can at least kind of see the Y axis. What do you think we should make the max? 13,000. Okay, why 13,000? Yeah, it's above that. We already know that there's a line at 12,500. 13,000 is a good choice. All right, so I'm going to click OK. I'm going to give you a minute. Go ahead and put those on there. See if we get it to appear. All right, did it show up? Yeah, not too bad. I can't really see the bottom very well, but that's because this is so... I have to find the point of intersection, which is right there, which is okay. I would probably either drag the graph. So notice, I could take it and I could drag it to get a little better handle on that. Or I could go back here, go menu. When you do the dragging, notice it changed all my numbers there. Okay? I'm going to make that 15,000 instead. I'm just going to adjust it a little bit better. Oops. Did I hit 100? Yeah, it disappeared. So 15, I missed a 0. All right. So that's a little bit better, okay? I probably didn't need to do 1,000, but that works. Okay, we got it up there. I think I did 500 last period. All right, so what we're supposed to do is calculate points of intersection. We're going to do that with the calculator. So I'm going to go to Menu, Analyze Graph, and Intersection. Okay, and I'm going to go to the left of it. I'm going to keep dragging until I see the point pop up in the word intersection, and to the right of it. And that's what we're going to write down as our work. So probably what I would do is I would sketch it, since you were told to graph it, and then write down that point. So I would sketch it and then make sure that you have written down 482.831 12,500. All right, you ready for the next one? Okay, so on the next one here, We have to graph it again. Part A says that we have to use the graphing utility to graph it, and then find open intervals and maxes and mins. So let's all get that typed in. I'm gonna do it with you. So I'd probably doc B all that hard work we just did. Yeah, well, that's what happens. All right, and then we're gonna do 2x squared, and then e to the x plus 1. And then go ahead and hit enter. All right, I'm going to hit enter. All right, the next thing I want to do is, because I have to do increasing and decreasing intervals and maxes and mins, I might as well calculate the max and the min. So I'm going to do my max first. So remember, you go to Menu, Analyze Graph, Maximum. We're going to go to the left of it, to the right of it. I'm going to kind of drag it so I can see it. And I know that that looks like 0, 0 on the min, but I want to verify that. Because it could be 0.000 something, right? It's just really close to 0. So you want to make sure that it is, in fact, 0. And then go ahead and sketch that and label it. So I'll give you a minute to do that. Sketch it and label it. Okay, so let's talk about where it is. We have to talk. B was decide where it's increasing and decreasing. So let's talk about increasing and decreasing. So increasing means going up. Remember, we're going to use our interval notation that we learned. And remember, we only talk about our x values here. So what x value is it starting the increase at? Good. So remember, that arrow means we're going off to infinity, and it happens to be going negative infinity. Where does it stop increasing? What x value? -2. Good. And then does it increase somewhere else? Yeah, where does it start increasing again? 0, and it stops increasing at infinity. Good. All right, what about decreasing? This little chunk in here where it's going down. What interval is that? Good. All right. Then we need to talk about maxes and mins. So basically we're going to read the numbers off the graph, right? So the max was -2, 2.943, and the min was 0, 0. Okay. The rest of the lesson is going to be the application of these, which means we're doing word problems, right? There's good news, though. There's a formula. So we like it in math when there's a formula, right? That we can easily apply. All right, so go ahead and fill in that first word there. So here's an important one for you. This will become very important to your life, some of you sooner than others, okay? When you go out into the real world, you're going to probably need a loan or need a bank account somewhere, okay? So we're going to talk about interest. So one of the most common places that E is used every day in applications is compound interest, all right? So the formulas are down here, so if you can't read my handwriting when I squish it in there, they're down here at the bottom, okay? So if the interest is compounded n times per year, then the amount in the account is A equals P, and I'll talk about what the letters mean here in a minute, times 1 plus R over N to the NT power. Again, if you can't read that, it's this formula right here at the bottom. But there's another formula, okay, and another way we can compound things. If the interest is compounded continuously, The amount in the account is A equals PE to the RT. I call that the shampoo formula. Because there's a shampoo called Pert. Or there used to be. They told me last year that it still existed. So I don't know because I shop at Costco. So I don't get my shampoo at Target. So all right, the question is, what do all those letters mean, right? So we have A is for the amount that you get in the end. Okay? Because we're talking about money, P stands for the principal. And all that the principal means is that it's the initial amount. So notice I didn't spell it like principal, the guy who runs the school, right? What do you think R stands for? It's a rate, yep. And then N is the number, and that's not a hashtag, it means number of compounds. Back in the day when I went to school, that meant number. We didn't have cell phones. Okay. We good? Everybody's got those written down? Now here's the thing. When we talk about the number of compounds, you also need to know how many times, or some numbers about how many times it's compounding. Okay? So not only are we expecting you to know those two formulas when it comes time for the final in 2 weeks, okay? But you need to know these numbers. All right, we'll see if you can do better than first period. All right? And these are all related to a year. Okay? So how many of these things in a year? So how many days in a year? Good. What about weeks in a year? There, that's much better. They were all over the place. Okay. How many months in a year? 12. Good. All right, how about it quarters? 4. Biannual, how do you think that is? 2. And then annual is 1. So you do need to know those numbers. Those are the ones that are most commonly come up. Okay? All right, so let's try one of these problems. So it says we've got a total of $9,000 invested at an annual interest rate of 2.5% compounded annually. Find the balance in the account after 5 years. This is a pretty straightforward application of the formula. If it was me and I was trying to learn a formula the 2 weeks before the final exam, on every problem, I'd probably write that formula out. Okay? Remember when you were in elementary school and you learned your spelling words by writing them out? All right? You can do the same thing to learn a formula. All right? So every time you do a problem, write it out. All right, so A equals P times 1 plus R over N to the NT power. And we know we're using that formula because it says the compound is annual. If it said continuous, then I know I used the PERT formula. Yes, Ruby.
Is it RT or NT?
It's NT. All right, so amount is what I'm finding. What's the principal, do you think? Which number? 9,000, good. All right. One thing you should write out in the left-hand column is that we want to convert, so put this out as a note to yourself in the left-hand column. You want to convert the percent to decimal before you put it into your formula. So so this is my R. How do I convert that to decimal? You move it over to which direction? Left 2. Okay, you want to make it smaller, not bigger. So 0 to 5. How many compounds does this one have? It says it's compounded annually. 1 compound. Okay. All right, so and then my N here is still 1. What's the time value, or the T? 5. And that's always measured in years. All right, we're going to let the calculator do all the rest of the work for us. Am I going to do divide by 1 in my calculator? Probably not. Okay, but if it was anything else, I would use the calculator to do that work for me. So let's do it together. I'm going to hit a doc B and get rid of what we got there. I'm going to go back to the scratch pad there. And we've got 9,000 times I'm going to type, not plus, times, and I'm going to go to the parentheses. And we've got 1 plus. Now, if I had to something other than 1, I'd probably hit a control divide, but I'm going to go 0.025. Close it, grab my exponent. I'm not going to do 1 times 5 because I know what 1 times 5 is in my head. Alright, and then I'm going to go ahead and hit enter. So wasn't it nice that we let the calculator do the work for us? Are you guys getting the same number I am? Was yours 0.7? Somebody at last period, a lot of them are getting 67. So either one is fine. You got 67? Okay. I don't know. Something's going on. Either my calculator's rounding funny or something, but so it would round to what I got up there. So you guys got the $10,182.67. Okay. So in 5 years, just by putting that money in the bank, without doing anything to it, you made a whopping $182.67. Okay. Oh wait, $1,082.67. Well, it's better than $182. Okay. All right. For doing nothing, just putting it in the bank. All right. Let's look at 16. So 16's similar. We've got, so I'm going to write out my formula again because I'm trying to memorize it. So A equals P times 1 plus R over N to the NT power. So looking through that problem, what's my principal? 4,000. Okay. 1 plus, what do we get? What do we have to do for the rate? 2 decimal places, so what am I going to write down for that rate? Okay, good. How many compounds this time? It says monthly. So my n this time is 12, so that's going to change things a little bit on how we put it in the calculator. And then I have to do the 12. What's my years or my time? 6. All right, I'm going to put one more in with you, and after this, you're on your own. Okay, so I'm expecting you to be able to do it after me doing the second one with you. All right, so I'm going to go 4,000 times parentheses 1 plus, and I'm going to hit a control divide. If you want to hit the division sign, that's fine. But I like the control divide because then it looks exactly the way I wrote it. 12. And then we're going to hit the caret button, and I'm going to do 12 times 6. You guys, even though I know what 12 times 6 is, if I type that number in wrong, I've got my answer wrong. So it's better for this case, because you know, if you're taking a test and you're moving fast, maybe you'll make an arithmetic mistake putting that in. Okay, but if I know that I type it and I can look exactly at what I have written on my paper and make sure it's exactly what's in my calculator, then I know I've got it right. Okay, are we all agreeing with the 2-7 this time? Yeah, I don't know why on that one problem mine did it weird. Okay, so on this one, we've got that it is $5,477.27. On 6 years, yeah. Yep. Okay, let's look at 17. 17 has us do a couple of things. So on 17, they give us the money, they give us the rate, they give us the years, but then they say there's 2 parts. In part A, they want us to go quarterly, and in part B, they want us to go continuously. Okay? So part A is our same old formula, A equals P times 1 plus R over N to the NT power. This one here is my PERT formula for continuously. Okay, so let's start plugging numbers in. So, what's my principal? 12,000. It's a pretty good principal. All right, what's my rate? Okay, so how would I put that into the formula? 0.03. You got to move this twice. Okay, and then it says that our compounds are quarterly. What would I do for quarterly? 4. Okay, and then to the 4, and what's the time that they gave us? 4. All right. So before we do part B, I want everybody to put that in your calculator. Everybody needs to practice, because remember, I can't help you when it comes time for the test. You have to make sure you're inputting it correctly. All right, what do we get?
13,523.9.
Was it 91?
Yes.
Okay, some people got 90, some people got 91. Is that right? Yeah. Yeah, the calculator was doing weird things. All right, I'll take either one though.
They rounded like a bank would.
Yeah. It rounded down. It did, yeah. All right, let's talk about this next one here. So now I'm going to go continuous. I'm using a slightly different formula. So A equals, what's my principal again? 12,000. And remember, E is the button in your calculator. That's a number. What am I going to write for my rate? 0.03 again. And then my time is 4. All right, put that in. I'm going to let you try putting that one in. All right. What do we get on that one? 0.96. Okay. So here's the deal. This is a very small, I mean, it's a fairly small amount of money. But let's talk about what this is in real life, okay? So if I was going to the bank and I was trying to open a bank account and I was shopping between banks, okay? Which one is a better deal, compounding quarterly or continuously? Continuously, right? So I want to shop the bank and go to the bank that's going to give me that continuous rate. Now, does that happen? Probably not, okay? But it's a good question to ask how many times they compound when you're opening a savings account, okay? The other thing is to make sure that that rate is as high as it possibly can be, okay? Now let's talk about the other situation. What if we were talking about a loan? Which one do we want now? You want quarterly. So it's almost more important on the loan than the savings account, right? How many times are you going to compound compound my interest on my loan, okay? And how many, because you don't want a continuous compound. You want it to be compounded like biannually, right? Or annually, which that never happens, all right? And then you want that rate on a loan to be as low as it possibly can. And you'll notice student loans, that's usually the lowest interest rate, right? Car loans are usually the worst. Okay, car loans are sometimes 17, 18%. Credit cards are bad too. So, all right. So that's your real life lesson for the day. All right, so we're going to switch from money to science. Okay, here's your chemistry example. Okay, and I'm going to see if I can pronounce it right this period. I'm not sure I will. All right, so let Y represent the mass in grams. They gave us a measurement of radioactive strontium. Did I say it right? Strontium. Okay, strontium, whose half-life is 29 years. The quantity of strontium present after T years is this. They gave us the function. There's no reason you shouldn't be able to answer this. Okay? All right. What is the initial mass when time equals 0? What do you think we're going to do? Plug it in. That's all that there is to do on this. 1/2 to the 0 over 29. Okay? So watch this. So 0 divided by 29 would be 0, wouldn't it? Okay. What's 1/2 to the 0 power? Anything to the 0 is 1, right? So 10 times 1 is 10. And we would label this in grams. Okay. Let's look at part B. It says, how much of the initial mass is present after 80 years? They did not explicitly say that T equaled 80, right? But that's what it is, isn't it? That's your T value, because it tells you in here T is years. So let's plug in the 80. So we're doing the same thing. We're putting the 80 into it. All right, I'm going to let you put it into the calculator. I'd probably at least use the control divide on this 80 divided by 29, okay? And maybe if you don't want to put in the 1/2, you could put in a 0.5 if you want. All right, so go ahead and calculate that. Take a minute and try it. All right, what do we get? 3 decimals. It only gave you 2?
It only gave us 2 sig figs in the problem, so it only gave
No.
us 2 sig figs.
We were getting this last period.
Yeah.
Okay. All right. So, and label it in grams. All right, so that's the chemistry example. Now we're going to do the biology example. The other thing they like to calculate is fruit flies. I don't know why. All right, but they do. All right, we're not going to do part C, so you can cross part C out. Because you could graph that with the calculator. I'd expect you to be able to do that if I gave it to you, but we're not going to. All right, so we've got the approximate number of fruit flies in an experimental population after T hours is given by that function. Again, they gave it to you, okay? Find the initial number of fruit flies in the population. What are you going to put in for T for the initial number of fruit flies? 0, right? Because your initial amount starts at times 0. All right, so you had to figure that out. They weren't explicit about it. All right, so we're going to do Q of 0 equals 20 e to the 0.03 times 0. All right, what's 0.03 times 0? Good. What's anything to the 0 power? Did you notice on both of these problems that when we put in a 0, the initial amount was always this number in front? Yeah. And don't these functions kind of look like that? Yeah. It's really, this formula can be used for a lot of exponential things. When we go to calc, we change that to an A instead of a P. Okay? So it's basically an exponential formula. All right, and then we would want to label that as 20 fruit flies, because that's what we're measuring. All right. Then in part B, it's asking how large is the population of fruit flies after 72 hours. So what are you going to do for that? Plug in 72 for your time. Awesome. So 20 e to the 0.03 times 72. Okay, go ahead and plop that into your calculator. All right, what do we get?
173.
Was there a decimal after it?
There's a decimal. We can't part of the fruit fly.
What was the decimal? 423. All right. All right. But Bryce is right. We want to go to 173 fruit flies because you don't want part of a fruit fly. Okay? So now think about that. We started with 20, right? And in a little as 72 hours, we have 173. Think about how many flies are next door. Okay? And how fast. So think about fly population is exponential. That's why that we on an exponential we have that super steep curve, right? Because it just goes and goes and goes really, really fast. That's why we have some days where there's a huge problem over here, right? We have 1 million flies. Okay? All right. Homework is in haiku. All right, you've got a lot of time today. Get started on it. You might be able to get finished with it. I'm going to hold off on, if you really want to stamp, you can come see me. I haven't even printed the sheet yet for last week. Last period wasn't ready yet, so I didn't stamp last period. Okay? We will try to make some time for stamping. Tomorrow's lesson should be short, so how about we stamp tomorrow? How's that sound? Okay? All right. So, I'm going to let you guys at it and stop talking.